You are in the meeting now. I want you to hear this, so I'm going to leave the mic on for sure.
Okay,
Is that good?
Turn it off for now.
Oh.
Turn it off for now.
Turn it off for now? And you... That's cool? You can hear me okay?
Yes.
You can put it up.
Oh, are you? Oh, then you said it.
Yeah.
Oh, I...
I will just introduce you.
All right. Good.
Good morning, everyone, and welcome to our last Grand Round session for this academic year. And for that, I have a special guest today, Dr. Mark Elliott. He's always very entertaining and thought-provoking, so for a few days you'll think about what he actually said today. At least that's my experience from previous talks. For those who haven't had a chance to know Mark, he's a staff anesthesiologist at Providence Health. He works mainly at MSJ out of his choice.
Only.
He's an avid biker. He cycles a lot. He has two bright kids who I think are computer geeks. A little off the scale in the IQ department, I think.
What a con, eh?
He occasionally writes articles for the BC Journal of Medicine, and I think just in April of this year he had one on the upper airway, which is kind of interesting, kind of a multidisciplinary involvement in what upper airways mean and all that. So without further ado, I'll let Mark take over. Please remember to mute your mics as well and enjoy.
Okay. All right, so I won't touch anything on this thing except the table. Nothing. I'll touch nothing. One button. Jeez, that's a lot of work to get this going. Hello. Jeez, the crowd is overwhelming here. Hold the applause for a minute. Just till the end. Okay, so I need glasses these days, so here we go. And everyone can hear me. Okay, so here's the objectives that I'd previously distributed, and I'm sure you've all memorized them. Not. This rounds are not really about philosophy. They're based, there's no Nietzsche, And these rounds are basically about three guys who've made an impression on me. Carlo, Stu, and David. And I want to show you how the work of these three guys can allow you to perhaps change your framework. I want to show you perhaps that at the heart of some of the most important stories we've been told, there's an assumption that could be wrong. I'll try to tie it to anesthesia, but that's a bit of a stretch. But we'll see what happens. First objective, what is a 15-minute time unit? And for this, we're going to talk about Carlo's stuff. Carlo Rovelli is an Italian physicist. He wrote a popular book. It's called 7 Brief Lessons of Time, which 7 Brief Lessons on Physics, and it sold 1 million copies. But the concept I want to get to you today is from his most recent book called The Order of Time. And this is where I stole the 15-minute idea from, or I should say the presentation of the 15-minute idea, because the idea has been around for a lot of years and has been the result of many decades of work by many people. So let's talk about time. We all know about time in anesthesia. Anesthetists are generally fixed to a clock all day, either that little white digital readout at the top right hand of the monitor or the OR wall clock. We know very well what 15 minutes is. It's a dollar value that varies according to the MSP fee schedule. So by this definition, we're already a little bit more malleable in our outlook as to what time actually is. But we know that 15 minutes is one pay unit. But wait, 16 minutes, or more commonly 20 minutes, is 2 time units, or 30 minutes. You get the idea. I just want to make the point that we're maybe a little more lateral in our thinking about time than our surgical colleagues, and you're going to need this attitude for the next few minutes. Humans think of time as a long line, a sequence of moments ordered in one direction. There's a past that's only there because it's recorded in something in the present. The past is fixed. It's fixed in the things in nature like craters on the moon or the limestone with fossils in it up on a mountainside that used to be on the ocean floor 500 million years ago. The future's open. Some say that the only thing that really exists is the present. Presentism is what philosophers call this versus eternalism. Basically, philosophers just take one word, add ism to it, and create a whole specialty. It's exactly what we do in medicine. In any event, this past, present, future thingy is not really the case outside our little earthly bubble. So we're going to move to a different framework where this becomes more apparent. Think 3 dimensions rather than just 1. Another analogy would be to let's proceed by peeling away the layers of an onion to see what's at the center. And let's look at our obvious assumptions about time and see what happens when we're wrong. And we'll do this in 4 steps. First step, clocks. We measure time with clocks. Clocks are designed to work together. 2 clocks in the OR say the same thing, even though one's up at the wall and one's at eye level on the machine. But this is wrong. Speed slows time down. This is a schematic of the famous 71 experiment which showed this. We're now going about that way east at 1,000 miles an hour. So if you get into a plane and go 500 miles an hour, time will slow down exactly as the Lorentz transformation in the equations of relativity say. It's not much, but it's exactly like it says. This was confirmation of Einstein's famous 1905 special theory of relativity. The OR clock is running faster than the machine at eye level. This is because mass slows down time. The more mass closer to the Earth, then the clock ticks slower. This was Einstein's famous general relativity theory in 1915, 10 years after plain old relativity. So at the surface of a black hole, there's no time. Time stopped. Same with speed. A photon going at the speed of light, there is no time because time has slowed to 0. This is the first step. It's complete. First layer of the onion skin off. Second layer, what's the meaning of now? If I look at you, I see you now. But it's not really now, is it? You know, I know it's now, but yet again, this is wrong. It takes time for light to come to me from you guys. But if you guys were on Jupiter, it'd be 40 minutes. If you're on the nearest star, it'd be 4 years. Therefore, it's not really when I see you. It's 4 hours in the future if you were on Jupiter. Second layer of the onion skin's gone. Third layer, the past is different than the future. The equations of physics, except thermodynamics, don't have this distinction because they're all time invariant. The equations are true backwards and forwards, but we know the Eggman does not reform a broken shell when he falls off the wall. Thermodynamics is the only science that gives us a narrative for why this is, and it's a strange story, so we'll need a little bit more history other than I Am the Walrus by the Beatles and Lewis Carroll. The French Revolution was a time when a lot of sciences were revolutionized. The social revolution went hand in hand with the scientific one. The first revolutionary mayor of Paris was an astronomer, and Lavoisier, the great chemist, was active in politics, so active, in fact, that the revolutionaries cut off his head. And Lazare Carnot was known as the organizer of victory in the French Revolutionary Wars. Carnot had a passion for the Persian poet Sadi Shirazi, the author of these verses. These words now stand at the entrance of the UN in New York. Carnot was so enamored with this poet that he named his first son Sadi. And as a young man, Sadi developed a passion for steam engines that were changing the world by making fire turn an axle in a steam engine. In 1824, he wrote his famous pamphlet about his theory of how this fire turns the axle. He thought, wrongly, that heat's like a porridge that falls from top to bottom, like a waterfall, and creates this energy to turn the axle. He was wrong, but he was right about the heat business. The Sadi's pamphlet finds its way into the hands of the Prussian professor Clausius. He sees the crucial point right away. If nothing else around changes, heat cannot pass from a cold body to a hot body. The crucial point here is the difference of what happens with falling bodies, or comparison to that. A ball can be dropped, but it'll bounce. Heat can't. Heat comes up with that famous entropy thingy. The change in entropy is never less than zero in a closed system. That last phrase is the key in a closed system. But the real insight is left for the tragic Ludwig Boltzmann, who committed suicide when he was on vacation with his small child and wife, in no small part due to being mocked by the scientific establishment of the time. You see, he believed in atoms. Many at the time did not. He believed the more they jiggled, the more heat there was. Many at the time did not. And he believed the answer to time was statistical. This thermal agitation, this jiggling, is like a continual shuffling of a pack of cards. If the cards are in order, the shuffling disorders them. In this way, heat passes from hot to cold, not vice versa. The growth in entropy is nothing other than a natural increase in disorder. Boltzmann understood this difference between the past and future, and he realized it doesn't lie in the laws of motion. It's in the natural disordering of things that leads to more gradually less particular, less special situations. The possible number of shuffles is huge. Whenever you see log in a formula, it just means take a big number and we'll try to make it a little more understandable. This is the famous equation that he came up with. It's on his tombstone in the Central Cemetery in Vienna. Now just consider the ordering of a pack of cards, 52 factorial. Remember that one, 52 times 51, down, 4, 3, 2, 1. Now that number, just think of that number. That number is 10 to the 68th. Now just think of it for a second. The hugeness of this number, as Trump would say, means that the vast majority of shuffles have never taken place over the billions of years on the planet by the thousands of years by billions of people. Just to drive the point home, take the 10 commonest words in English. That can be arranged in 10 factorial possible sentence of 10 words. 10 factorial is 3 million combinations, but only a handful are going to be understood as sentences. It's big, almost incomprehensible numbers we're talking about here. And a phrase you might hear if you read about this type of stuff is exponential combinatorial explosion. Now remember all that stuff from high school, the red and the blue balls, low entropy versus high entropy, ordered on the left, low entropy, shuffled on the right, high entropy. The universe only goes one way. Now if you showed this concept to a friend who's colorblind, it would mean nothing to him. But let's say your friend has the ability to distinguish the fact that half of the balls are a little bit bigger than the other half. This is exactly the same as being able to see the cards ordered with respect to suit versus ordered with respect to number. The disordering or the measurement of this disordering is chosen by us. We choose how to interact with the system. We choose blue or red, big or small. So Boltzmann's idea was correct, but it doesn't really show you the past versus the future. It just shifts the question. The question becomes now, why in one of the two directions of time, the one we call past, was entropy lower? Well, I'll tell you why. Entropy was lower yesterday because it was lower the day before, and it was lower last year because it was lower 2 years before that. And that's the end of the story. Just accept it. Except there's a mammoth in the room. And that mammoth is called cosmic background radiation. And it looks like the famous Planck curve for black body radiation. The details are totally unimportant. But what it means is as you go back in time, things become smoother and smoother and smoother. And then you get to the Big Bang, and things are totally smooth. It's totally smooth is the Big Bang. It means that smooth means maximal entropy. So things are getting smaller, 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 and then they're at a maximum. Doesn't make any sense. That's not an unknown paradox in physics. Anyway, fourth layer, biology. A good reference for this is a recent book by Dean Bonomano at UCLA called Your Brain is a Time Machine. Neuroscience has shown us that human brains are better with space evidence than time evidence. This is taken to mean that sometime in the past, evolution co-opted areas of the brain used to understand space to understand time. All languages have phrases like, we had us a long day, I'm looking forward, and hindsight is remnants of this development, supposedly. Time's the most common used word in the English language. We find time, lose time, save time, spend time. In antiquity, we measured space better than time, and it's just the opposite nowadays with atomic clocks. In the days of yore, we had daylight cycles that our brain measured. People had longer hours in the summer than they did in the winter. But then the electric telegraph was invented, and that was instantaneous compared to a stagecoach carrying a letter. A lot of Einstein's job, actually, at the patent office was all about this. He realized the impossibility of a universal time, so we got time zones as an approximation. Here's Dean doing a talk where he basically says, that you can check out, that he basically says the brain connects the past with memory and the future with anticipation. This is not a new concept. St. Augustine said this about 1,600 years ago. The neuroscience is saying that we're the time machine, not the universe. Or in other words, the second law of thermodynamics is the first law of psychology. This talk will end on time. That's natural time, by clock time, but it sure seems to be taking a long time. That's subjective time. Perhaps time has something to do with human reaction time, which is about 1/10 of a second. Typically, a human takes about 100 milliseconds to register a fin prick and pull the hand back. A fly only needs 10 milliseconds. That's why to the fly, if you try to kill it without a fly swatter, your hand and arms seem to be moving in slow motion. Here's how to think about it. Here's the Earth. It's about 12,000 kilometers across. Here's you on the surface of the Earth. And around you, there's this big bubble of 100 milliseconds. Multiply this by the speed of light, so 1/10 of a second times 300,000 kilometers a second, you get about 30,000 kilometers. Inside this bubble of 30,000 kilometers, our biological approximations are okay. Outside this sphere, it's a completely different world. For the fly, with a reaction time of only 10 milliseconds, you get a bubble of about 3,000. Can we apply this to anesthesia? Well, no, not really. This little bit of philosophy won't change your billing practices, but it hopefully gives you something to think about when you're writing on your timesheets, and maybe that OR wall clock looks a little different now, just like it did for Salvador Dali. Second objective, how thermodynamics and calculus are great for physics but not biology. This has to do with Stu's work. Now, Stu Kaufman finished medical school in '68. He practiced for a short while, and then he went on to become one of the originals at the Santa Fe Institute, where he basically did math as applied to biology. He was awarded a MacArthur Genius Grant. He wrote 6 books. He published hundreds of papers. He has more patents than you can shake a stick at. Here's a more recent picture of him on Closer to Truth. He'll tell you he's a fruit fly geneticist only. He spends a lot of his time actually now just south of us on Crane Island in the San Juans. I want to tell you about his ideas. Now, nobody's ideas are really new. Like Whitehead said, everything of importance has been said before by someone who did not discover it. Kirby Ferguson says the same thing. All content is just copied, transformed, and remixed. Stu reminds me a bit of Spinoza. 1993. We'll go over some of his books, sort of, and ideas sort of in a non-sort of organized way. The origins of order shows us how complex things in the biosphere develop spontaneously. But is this process random, or is it following natural laws? In statistics, there's something called ludic fallacy, where we believe the world can be modeled with probabilities that are like coin tosses. But the outcome of a coin toss is just a reflection of our lack of knowledge about the coin toss, the gravity and the air currents and all that stuff. You could argue that once you knew all this information, you could predict the outcome of a coin toss. And in fact, there are machines that do that now. This is called an epistemic problem. Epistemic questions have answers, but you don't have enough information yet to answer. Ontological problems are ones that you cannot know the answer to, no matter how much information you have. Theoretically, you can predict the roll of a dice, but a alpha decay from a uranium nucleus is an entirely different beast of a problem. This is the monstrous randomness that lies at the heart of quantum mechanics, and the randomness itself, is reality. It's not just a reflection of our lack of knowledge. 1995, At Home in the Universe, is sort of about the origins of life. He starts with a weird thing called random graph theory, which was one of Paul Erdosh's big things. Google this guy if you want a real story. If I take a bunch, random graph theory just says, if I take 1,000,000 buttons, I throw them on this ground here and then randomly throw a string, one after the other, that attaches 2 buttons. And I just keep doing that, and every once in a while I pick up the strings. Well, you pick up 2, you may pick up 4, but generally it's real small numbers. And then all of a sudden, boom, you throw one more string down and the whole goddamn thing comes up. That is a phase transition. And Stu applies this to biology with something he calls autocatalytic sets of polymers, which basically means A goes to B, goes to C, goes to D, back to A. So what he's saying is he goes deeper than Darwin and DNA, basically saying that biological reproduction does not require template replication. By the way, the current rage in this now is the hydrothermal alkaline vents at the bottom of the ocean, which allow energy to be used from hydrogen ion gradients to stop little holes at the base of those rocks with something that looks like life. These holes, by the way, are just about the size of a bacteria, curiously enough. 2000, investigation. There's a difference between pool tables in physics and fish bladders in biology. Pool table equations are time invariant. You can't tell forward and backward. You take the balls, measure the momentum and position, plug that into an equation. The engineer then tells you where the balls are in a completely deterministic way. Physics is good this way because it makes ridiculously simplifying assumptions about that make things much easier, like the frictionless surface that high school teachers torment their students with. Actually, interestingly enough, if there was no friction, there'd be no time. Like that scribe in the Middle Ages drawing things. If there wasn't friction to heat up the thing and record it, there'd be no time, just as an aside. But in biology, things are different. A rose wilting is much more complex. You don't know what the initial conditions are of this pool table, and even if you didn't, you could not integrate the equation because the boundary conditions, the sides of the pool table, are always changing. Think about a swim bladder that develops in an ancient lungfish. Some air gets into the outpouchings of the esophagus. If this happens on the back, it's a swim bladder 200 million years ago, later, that allows for neutral buoyancy in the water, but also a whole new world of organisms to grow in that fish bladder. If it happens on the ventral surface of an animal, it becomes an amphibian 200 million years later that goes up onto the land. Darwin actually understood this very well. In one of the later editions of his Origins of the Species, he addresses this by the famous 5 words, by a change of function. 2008, reinventing the sacred. We think biology is explained by biochemistry, biochemistry explained by chemistry, chemistry explained by physics, etc. But Stu points out that all the arrows don't point downward. The universe doesn't just march along from one moment to the next, depending only on the present with no purpose. There are interactions between things that generate new information that can't be known beforehand. This creates, agency, value, meaning, all that stuff. Here, in this book, Stu basically replaces God with human creativity. 2016, Humanity in a Creative Universe. Stu likes to talk about Kantian wholes, after the famous Immanuel Kant. The whole exists for and on account of the parts, and the parts exist for and on account of the whole. which means, according to Stu, that there's no such thing as entailing laws. There's only enabling laws. But the most recent book is 2019. It's called A World Beyond Physics, and I want to tell you about ergodicity. Thermodynamics and entropy are great for engineering that went into the design of the vaporizers on the gas machine. Thermodynamics and entropy are based on an assumption. That assumption is ergodicity. All those red and blue balls in that one slide go everywhere in that box. Eventually, the mathy word for this is that all of phase space is explored. But in biology, this is not true. Now, think about the following example of Stu's to illustrate this point. I found this very interesting. The average size of a protein in your body is 200 amino acids. There are 20 amino acids. The possible number of average proteins of 200 amino acids is therefore 20 times 20 times 20 times 20, 200 times, right? Each spot has 20 possible choices, so the combinatorial of this is 20 to the 200th. That's 10 to the 256, just to put it in a more common base, 10, so we can use our fingers. There are 10 to the 80th particles in the universe, supposedly. And now if every particle in the universe made a 200 amino-sized protein every 10 to the minus 44 seconds, which is the lowest amount of time you can get, called Planck time, and let's say they've been doing this for 10 to the 17th seconds, which is the time the universe has been around, that means that you could make 10 to the 141 proteins in the history of the universe. So based on these assumptions, it would take 10 to the 115th lifetimes of the universe to make all possible proteins. And seeing how we've only had one universe, or so the story goes, it's clearly absurd to think that the biosphere is functionally, which based on proteins, is functionally based on protein, is ergodic. It's markedly non-ergodic. Therefore, in addition to our calculus being wrong, in biology, our thermodynamics is probably wrong in biology. Now, how in the world can you apply this to anesthesia? Well, the next time you're doing a case and you look at this type of setup, take a look at the vaporizer. Wonderful engineering based on thermodynamics and calculus. It can give you a perfectly predictable concentration of sevoflurane. Now look at the patient. You can't really predict which patient's going to get anaphylaxis, can you, with the same accuracy as you can a SIBO concentration. Last objective. How am I doing? This one will be quick. Now, the last objective, why there's nothing stopping two diametrically opposed points of view from both being absolutely wrong in anesthesia. And this has to do with David's work. Now, David, I want to tell you about some of David's ideas and maybe apply the last one to anesthesia. Now, David Deutsch is considered the father of quantum mechanics. At least he generalized all that Turing machine, Malcolm Cumberbatch, imitation game, halting problem, all that stuff. He generalized it to quantum computers. Here's a more recent picture on Closer to Truth. David has written two books. The first is called The Fabric of Reality, where he shows how to combine the theory of the multiverse with the theory of computation, with the theory of evolution, with the theory of knowledge into something he calls reality. Brilliant book. The second book is called The Beginning of Infinity. Totally brilliant book. After reading this book, if you do have a chance, you'll have a tight definition of what science actually is. You'll understand why it's rational to be optimistic. Matt Ridley is actually right. You'll see that humans have always created more knowledge and always escaped the Malthusian trap, despite what the Swedish teenagers are saying. For instance, the difference in time between these two pictures is 80 years. U.S. Civil War and the atomic weapon. Difference here is only 66 years. You'll get a different view of what AGI is, artificial general intelligence, general being the key word. And you might even see that beauty is objective. But the one fundamental argument I want to get to you guys is the following. Mankind stagnated for many, many thousands of years, even though the brains of those humans were exactly like ours. But they basically suffered. Like Thomas Hobbes said, life was nasty, brutish, and short. And then something happened. And that's something, according to David, with explanations. This simple thought, explanations, not myths or dogma, explains all that testability stuff and all that scientific method stuff and all that enlightenment stuff. According to David, it was explanations that did not vary. And his prime example of that is the explanations for the seasons. The Greeks' explanations for the seasons was that Hades, the middle figure in the painting, god of the underworld, kidnaps Persephone, the goddess of spring, and negotiates a forced marriage contract with her, so she has to come back to hell to see that bastard every year. Now, her mother at this time is very sad. She's the goddess of the earth, Demeter, and when she's sad, she makes the earth cold. Well, this was a bad explanation because you can substitute all sorts of other godlike explanations. But an explanation that doesn't vary is that the Earth's axis is tilted and rays coming in straight are hotter than ones at an angle. This explanation doesn't vary, and it doesn't vary all the while it's explaining all the details of the phenomenon that it purports to explain. Here's David giving a talk a few years at TED that you can look up. And the really cool idea of this talk I want to try to get through to you and relate to anesthesia is that if you have two diametrically opposed points of view, there's nothing that prevents both of them from being wrong. David's example is the spaceship Earth hypothesis versus the principle of mediocrity. The spaceship Earth reasoning says that the Earth's a very special place. It's a miracle life support system. There's a water cycle, there's a carbon cycle, and it keeps us alive, and we're screwing it up, and we'll screw it up so bad that we'll all die. Not true, says David. The Earth has always been a death trap. For most of human existence, the harshness of the Earth killed people very quickly. What saved us was explanations which allowed for technology like clothing. So we're decoupled from this death trap. If any of us here were plunked down in Vancouver, when what was Vancouver 1,000 years ago, we'd be dead in a few days without technology. Now contrast the spaceship Earth hypothesis with the principle of mediocrity, which says that the Earth is not special. Here's the famous picture viewed through one of the rings of Saturn of the Earth by the Cassini probe. The principle of mediocrity says that we are, just as Stephen Hawking said, typical chemical scum on a typical planet in a typical galaxy in a typical part of the universe. Again, not true, says David. If you want typical in the universe, you go any direction about 1 billion light years into intergalactic space where there's only one hydrogen ion or one hydrogen molecule every cubic light year. That's typical for the universe. How to apply this to anesthesia? Here's a story that might fit. When Providence first happened, the folks over at MSJ, which I was one of, thought nothing of doing fiber optic intubations. Forgive me if I bore you with this story. I've told it 100 times. Because of our population, we always just thought nothing of doing fiber optic intubations because it was less stressful on our coronary arteries, we thought. Then you people started coming over to our place, and I noticed they didn't do them that often. They just, you guys are more advanced with those fibers. I had those scopes earlier than we did. But I thought, boy, these guys are pretty cavalier. And you guys are probably thinking, boy, these guys are a little nervous Nelly. Well, that was in the days when you had 4 ORs and 20 patients and 20 intubations. Now, it seems that nobody gets intubated. So those two diametrically opposed points of view may not be like totally wrong, but they're certainly moot. There, I'm done. Thanks for listening. No Nietzsche, although I can attempt to ask questions if you have any. Thanks for listening.
As I say, I'm speechless. How about you? Well, I'll definitely check out the authors.
Oh yeah, it's worthwhile. They're very
that in the past, so it's very interesting. I guess nothing on the chat. We're all done. Well, thanks a lot, Mark.
Okay.
And
no Nietzsche. Nobody wants to know about Nietzsche. That's amazing.
Nobody wants to know.
all these anti-Christ people.
Okay then. Well, thanks a lot for this entire year for all the efforts and all the presentations that have been given, and we'll see you again in September under the coordination of Anne-Marie Madden, as you have heard.
Thanks so much, Juana. You did a great job.
Thank you.
Your call will be disconnected.